In this video, we're going to focus on functions. But first, let's review the concept of relations. So, a relation in the context of mathematics, it's a relationship between two sets. All right. So, let's recall that a set is a collection of any kind of things that in general share the same properties. Okay. And we call these things as elements or members of a set. Okay. And again, they can be just about anything: numbers, letters, objects, shapes, anything. For example, we can make a set that contains the first 10 polygons, or set of all primary colors, or in mathematics, we usually deal with numbers, right? So for instance, set of all real numbers, set of all integers, so on and so forth. So going back to relations, they show how the elements in the first set, so this is the first set, we call this set as the input set. Okay, so again, relations show how the elements in the input set are related to or connected with the elements in the second set, which we call the output set. Okay, let's call the elements as values. Okay, so from the input set, we have the input values, and from the output set, we have the output values. Okay, so what happens basically is that we manipulate the input values. In other words, we transform them, we convert them, we extract information from the input values according to a certain rule in order to obtain the output values. Okay, now this rule here, this rule may or may not be specified. It depends on the given relation, meaning we can have relations with very specific rules. We can also have relations with unspecified rules, like for example, we can make a relation between some random numbers. Okay, now let's try to make a relation with a specific rule. Okay, say we list down as input values, let's say 5 common colors. Okay, so we input, for instance, in this case, color names, okay, of 5 common colors. Let's say red, blue, green, black, and yellow. So these are the input values. Okay, and then we can establish a rule that says take the corresponding number of letters for each color names. Therefore, we output the number of letters. Okay, so in this case, red has 3 letters, blue has 4, green has 5, black also has 5, and yellow has 6 letters. All right, so we now have a relation. In this particular example, we associated each color or color name with its corresponding number of letters. Okay, now let's make another example of a relation, say between some random integers. Okay, so let's say we input -1, 0, 2, and 3. Okay, and then let's say we associate -1 with 2, and then 0 to -1, 2 to 4, and then 3 to 4 also. Okay, we call this manner or method of showing a relation as mapping. Okay, so this is a mapping diagram of showing a relation. Another way is through the use of tables. So basically, we just make a table, all right, and then from each input and corresponding output value, we can generate ordered pairs. Okay, for this particular relation, this is composed of 4 ordered pairs, and then we can group them together in a one set, indicated by open and close curly brackets, right? Now, we usually denote the input values as x values and the output values as y values, right? So an ordered pair is usually represented by x, y, okay? And we can go further by calling the x and the y values as x and y coordinates respectively, okay? Therefore, we can plot these ordered pairs as points in the rectangular or Cartesian coordinate system like this one, okay? So these are the ways we can show or present solutions. We can do it through mapping, through tables, uh, ordered pairs, or point plotting and generating a graph. All right. Now, remember I've mentioned earlier that we can denote the input and the output values as x and y values respectively, right? So here, the input is also commonly called as domain, and the output set is usually referred to as the range, right? So let's take a look at some more examples of relations. Okay, so we have here relation A. This is what we call a one-to-one relation, since each x value corresponds to only one y value. And in the same way, each y value corresponds to only one x value. That's why it's called one-to-one relation. All right. Next, we have here relation B. This is an example of a one-to-many relation. Okay. Notice that one of the x values, in this case -1, right? -1 in this case corresponds to multiple y values. Okay, and in this case in particular, we have two y values corresponding to a single x value, right? So two y values corresponding to a single x value. Hence, this is called one-to-many relation. Another type of relation is what we call many-to-one relation, okay? Like relation C that we have here. And as you can see, we have multiple x values, right? -1 and 0 that share the same y value, in this case 3. That's why it's called many-to-one relation, okay? We also have a relation known as many-to-many relation. In this case, it involves multiple x values that correspond to the same multiple y values and vice versa. Okay. Now, out of all these types of relations, we have a special type of relations known as functions. All right. Let's say this is the set of all possible relations, all right? And inside this set is a subset, a special type we call functions, okay? This implies that all functions are relations, but not all relations are functions, okay? So for a relation to qualify as a function, we have a condition, okay? It cannot have multiple output values for a single input value, okay? In other words, functions are not allowed to have more than one y value for a single x value, okay? So this is the condition for, or a qualification, if you will, for a relation to be called a function, okay? So let's go back to the previous examples and determine whether they are functions or just relations in general. Okay, so first, relation A, which is a one-to-one relation. In this case, each each input or x value corresponds to a single output or y value. Therefore, this is a function. Okay, so another way to determine whether a relation is a function or not is by writing the relation as a set of ordered pairs, like this one. Okay, here we check if none of the x values appear multiple times, then it's a function. Okay, so this particular example, relation A, is indeed a function because all of the x values appear only once. All right. Now, relation B, which is a one-to-many relation, this is not a function. It's just a relation in general. Okay, so let's put R. Okay, this is because it involves multiple y values for a single x value, which is exactly what we want to avoid from this condition, right? And if we write this set as, or if we write this relation as a set of ordered pairs, we shall see that one of the x values appear more than once, in this case, -1. Okay, this indicates that it corresponds to multiple output values. Okay, therefore, it's not a function. Now, relation C, which is a many-to-one relation, this is considered to be a function, okay, because it does not violate this condition. Okay, and if we try to check by generating the ordered pairs, we shall see that none of the x values appear multiple times. Okay, therefore this is indeed a function. Okay, so now let us focus on functions. Since functions are relations, they also describe how one set of values is related to another set of values according to a particular rule. Okay, the rule here specifically is a collection of mathematical operations that constitutes a mathematical expression, and in turn, this mathematical expression is used to relate the input values to the output values by way of an equation. Okay, so for instance, we have the input value as x. Okay, let's say we take the square of x, so that's x squared, and from x squared we subtract 4, for example. Okay, we now have a mathematical expression. Now, to get the y value, we can just simply equate this expression to y, and now we have an equation. Okay, so let's check if this equation is truly a function. In order to do that, we can assign some x values and then solve for the corresponding y values. So let's make a table of values. Okay, so let's say we use -2, -1, 0, 1, and 2, for instance. Okay, if x is -2, then we plug in -2 to the equation. So -2 squared, that's 4, right? So 4 minus 4, that's 0 in this case. Then plug in -1, so -1 squared, that's +1. 1 minus 4, that's -3. And then if x is 0, then y is -4, right? And then if x is 1, then we have here 1 minus 4, that's -3. And then if x is 2, then 2 squared, that's 4. So 4 minus 4 is 0. Okay? And then from this, ordered pairs will be generated. Okay? and then we can plot them and make a graph. Okay, this goes up without bound, this also goes up without bound. Now, another way to check for a function is through the use of the vertical line test. So basically, we just draw a vertical line anywhere on the curve, and then if the vertical line crosses the curve at exactly one point, like this one, then it is a function. All right. So in this particular example, no matter where we draw the vertical line, it will always cross the curve at exactly one point, right? Therefore, this is a function. Specifically, it's a quadratic function for which the graph is a parabola, like this graph here. All right. So let's have another example. Say we have y equals x minus 1. Okay. Then assign some x values and then solve for y. So let's say -2, -1, 0, 1, and 2. Okay. So you can assign any x values for the point plotting. Okay. So it doesn't have to be always -2 to +2. You can use any x value, right? So here I am using -2 to +2. If x is -2, then y is -3, right? From this equation, if we plug in -2. Now, if we plug in -1, that would be -1 minus 1, so that's -2. If we plug in 0, then y is -1. If we plug in +1, then we get 0 as the y value. If we plug in 2, then we get +1. Okay, and then these are the ordered pairs that will be generated. Okay, so -2, -3, -1, -2, and then 0, -1, 1, 0, and +2, +1. Okay, then again we plot them, which will result to a straight line. Okay, now regardless of the placement of the vertical line, if we employ the vertical line test, it will always cross the graph at exactly one point. Okay, so if we draw the vertical line at this x value, it will cross the curve or the line in this case at exactly one point. Okay, like this one also at one point. All right. Therefore, this is or this equation is a function, and we call it linear function because its graph is a straight line. Okay. Let's take a look at another example. So we have here y squared equals x. All right. Now, remember that x is the input and y is the output. Therefore, x is the independent variable and y is the dependent variable. This is why we first assign x values and then we solve for y. So in other words, x comes first before y. Okay. Now for this equation, it would be more convenient if we isolate just y on the left-hand side of the equation. Okay, so that we can easily solve for y by assigning values for x. All right, so what do we do to isolate y? In this case, we take the square root of both sides of the equation. Okay, so take the square root of both sides of the equation. This will result to y equals positive negative square root of x. Okay, and then we now assign some x values. Now, since it involves a square root, then we can assign some perfect square numbers for easier calculation. Okay. Let's also include 0. If x is 0, then y is 0. Now, let's use 1 for x. If x is 1, then square root of 1 is, we have here positive and negative 1. And then let's say 4. So, square root of 4 will get positive and negative 2. Right? So these are now the ordered pairs that will be generated. 0, 0, and then 1, positive 1, and then 1, negative 1, and then 4, positive 2, and lastly 4, negative 2. Okay, so we plot them, and then this will be the graph that will be generated. Okay, so let's now check using the vertical line test. Now, if we draw the vertical line here, the line passes through the curve at exactly 1 point, so there's no problem with this. However, if we move the line to the right, like at this x value, it now crosses the curve at 2 points. Okay, the same with the succeeding vertical lines. Okay, so 2 points. This one also crosses the curve at 2 points. This one also 2 points. So on and so forth. Okay, therefore, this graph of this equation, it fails the vertical line test, and so consequently we can say that this equation is not a function. All right, so as a summary, we define functions, or functions are special types of relations with the property that each input value or x value corresponds to exactly one output or y value, right? In other words, functions cannot have multiple output values for a single input value.